RM10 is an STM32 ARM Cortex-M4 based autonomous UAV project. This video demonstrates the first prototype destined for a test flight sometime next week. As you can see, the microcontroller receives input from a multitude of inertial measurement sensors over I2C, where it then takes input from a 4-channel RC receiver, processes these inputs, and depending on the conditions outputs a suitable servo output to the UAV. The flight modes covered in this initial prototype will test manual or bypass control, and the fundamental autopilot system of augmented fly-by-wire control and pitch roll stabilization. Here are just a list of components involved in the RM10 project as it stands now. For the IMU sensor fusion, a complementary filter was chosen for its simplicity and low computational cost. This graph shows the filtered output against the raw input from the accelerometer gyro. In order to facilitate bypass mode or full manual control, the servo output from the hobby RC receiver is measured by the microcontroller, and the result of quantization is shown here. An essential mode of the UAV is the capability for manual control, which is an absolute necessity given the legislative constraints of UAVs in South Africa, which require a remote pilot backup at all times. These videos show just the manual control of aileron, elevator, and throttle. This video just demonstrates the PID algorithms running on board to facilitate pitch and roll stabilization using 6 degrees of freedom on the 11 degree of freedom IMU. As you can see, when I tilt the board to the left and to the right, the ailerons compensate, and if I pitch the board down, the elevator compensates. When I shake or tap the IMU abruptly, the complementary filter successfully filters out the sudden readings coming from the accelerometer to provide a smooth orientation measurement.